My dear students, thank you for subscribing my channel. Given a 25 watt bulb emits monochromatic yellow light of wavelength 0.57 mu m, calculate the rate of emission of quanta per second. Okay, 1 watt is equals to 1 joule per second. 1 mu m is equals to 1 into 10 power minus 6 meters. Energy is given, wavelength is also given. Calculate the rate of emission of quanta per second. We know that E is equals to NHC by lambda. N is equals to Hc by lambda E. C indicates velocity of the light. Velocity of the light value is 3 into 10 power 8 meter per second. H is equals to Planck's constant, 6.626 into 10 power minus 34 joule seconds. Now substitute H. Substitute the values. N is equals to lambda E by Hc. Now substitute the values. 25 into 0.57 into 10 power minus 6 divides with 6.626 into 10 power minus 34 into 3 into 10 power 8. Simplify, you will get 7.1687 into 10 power 19. Third option correct. Statement 1. A spectral line will be observed for a 2px to 2py transition. Statement 1 is wrong. Why? Px, Py orbitals are degenerate orbitals. Energy difference is 0. Energy difference is 0. Spectral lines are not observed. If energy difference is not equals to 0, then only we are able to observe the spectral lines. 2px and 2py are degenerate orbitals. Correct. Statement 1 false. Statement 2 true. Given below 4 statements, units of luminous intensity is candela. Correct. Units of luminous intensity is candela. Prefix gypto is used for 10 power minus 21. Gypto is used for 10 power minus 21. Correct. Law of definite proportions was proposed by John Dalton. Wrong. Law of definite proportions was proposed by Joseph Proust. Wrong. Mass percentage of hydrogen in NH3 molecule. Calculate percentage of hydrogen. Weight of hydrogen is 3 grams. Total weight is NH3 total weight is 17 grams into 100. 300 by 17. 17.647, but here given 82.35. This is also wrong. So only 1 and 2 statements are correct. Question is incorrect statements. 3 and 4 are incorrect statements. Match the following. Number of carbon atoms in 1 gram molecule. 1 gram molecule is equals to 1 mole. 1 gram molecule of CO2. That means 1 mole of CO2 contains 1 mole of carbon atoms. 1 mole of carbon atoms contains Avogadro number of atoms. AQ. Number of molecules in 48 grams of O2. According to mole concept, 32 grams of O2 contains Avogadro number of molecules. Then 48 grams of O2 contains how many molecules? 48 into Avogadro number by 32. That is equals to 1.5 into Avogadro number. BS. AQ. BS. First option correct. Remaining you can calculate. Second period, the atomic radius of oxygen is greater than that of atomic radius of nitrogen. Nitrogen and oxygen are period elements. Period left to right atomic size decreases. So nitrogen atomic size is more compared with oxygen. But here given oxygen atomic size is more compared with nitrogen. So this is wrong. In oxygen atoms, inner electronic repulsions outweigh the effect of increased nuclear charge. Yes, correct. A is false, but R is true. Consider the following order against the mentioned property. Magnesium less than silicon less than aluminum less than sulfur less than phosphorus. Second ionization potential order. No, this is wrong. The correct order is magnesium less than, aluminum less than, silicon less than, phosphorus less than, sulfur. We know that atomic size is inversely proportional to ionization potential, and ionization potential is directly proportional to stable electronic configuration also. Based on that you can check. Na2O less than MgO less than Al2O3 less than P2O5 acidic strength. Correct. Carbon less than nitrogen less than oxygen less than fluorine. This order is wrong. Correct order is nitrogen less than, carbon less than, oxygen less than, fluorine. Nitrogen electron affinity value is very less. Why? Because of its stable electronic configuration. It is not ready to accept the electrons. So only incorrect order. First one is incorrect as well as third one is also incorrect. Assertion: the atoms in a covalent molecules share electrons, yet some covalent molecules are polar in nature. Correct. Polar covalent bond or non-polar covalent bond. There are two types of covalent bonds are present. In polar covalent molecules, the shared electrons spend more time near one of the atoms due to difference in electronegativity. This is also correct. For example, polar covalent molecule. Yes, consider polar covalent molecule. This is polar covalent bond or polar covalent molecule because electronegativity difference is not equals to 0. So A is true, R is true. R is the correct explanation of A. Match the following. First of all, CCl4CO2. Group number of carbon 4, chlorine valency 1, total chlorines 4, 4 plus 4 is equals to 8, follows octet. Carbon group number 4, oxygen valency 2, 2 oxygens, 2 into 2, 4. 4 plus 4 is equals to 8. It follows octet rule. CCl4CO2 follows octet rule. 1, 4. 1, 4, 2 options are there. Okay. Next, BCl3, AlCl3. Group number 3, total valency 3, 6. Incomplete octet. Incomplete octet BCl3 and AlCl3. B2. So correct option is first option. NO and NO2 are odd electron molecules. 7 plus 8 is equals to 15. 7 plus 8 plus 8 is equals to 23. Yes, odd electron molecules. Increasing order of bond strength. of O2, O2 2 minus, O2 minus, O2 plus. We know that bond order is directly proportional to bond energy. Bond order of O2 is 2, O2 minus 1.5, O2 2 minus 1, O2 plus is equals to 2.5. Calculate the total number of electrons. Total number of electrons is equals to 14. Then bond order is equals to 3. 15, 13, bond order value is equals to 2.5. 16, 12, bond order value is equals to 2.0. 17 electrons, 11 electrons, bond order value is equals to 1.5. 18 electrons, 10 electrons, bond order value is equals to 1.0. Bond order value directly proportional to bond energy. Based on that, O2 plus energy is more and O2 2 minus energy is less. Fourth option is correct option. Valency shell orbitals with paired electrons cannot mix with each other to form hybrid orbitals. Wrong statement. According to the definition of hybridization, the intermixing of atomic orbitals gives hybrid orbitals. The d orbitals involved in sp3d hybridization is dz square. sp3d hybridization is dz square, correct. If the hybridization is sp2d or dsp2, involved orbital is dx square minus y square. Statement 1 is false. Statement 2 is true. C6H6 gives rise to C6H12. Delta H value is given as minus 204 kilojoules. Heat of hydrogenation of each C double bond C in benzene. In benzene molecules, how many C double bond Cs are present? Total 3 moles of C double bond Cs are present. 3 C double bond C bonds are present. Energy is minus 204. Then each per one C double bond C, energy is equals to question mark minus 204 by 3. Simplify. 204 divides with 3, then you will get 68 minus 68. Second option is correct option. Essential conditions for a process to be spontaneous. What are the essential conditions? Delta G value must be negative or less than 0. Delta G value must be negative. And one more thing, according to second law of thermodynamics, overall entropy change is positive, which makes the reaction spontaneous. Delta S total must be positive. Remaining two are not necessary and sufficient conditions, not essential conditions. Based on that, fourth option is correct option. The average XEF bond energy is 34 kilocalorie per mole. First ionization of xenon is 279 kilocalorie per mole. Electron affinity of fluorine is 85 kilocalorie per mole. And bond dissociation energy of fluorine is 38 kilocalorie per mole. The enthalpy change for the reaction. What is given? Bond energies are given. If bond energies are given, then delta H is equals to bond energy of reactants minus bond energy of products. What are the reactants here? Reactants are XeF4 is the reactant minus bond energy of products Xe plus F minus plus F2 plus F. Now XeF4, in XeF4 molecule, how many XeF bonds are present? 4 XeF bonds are present. So 4 into XeF bond energy is given as 34. 4 into 34 minus Xe plus ionization energy. Ionization energy of xenon is given as 279. plus electron affinity of fluorine. Here read, group 17 elements have very high negative electron gain enthalpy. For group 17 elements, the electron gain enthalpy values are negative. Here positive value is given. You must take negative. So minus 85 plus bond dissociation energy. What is bond dissociation energy? Break the bond between fluorine and fluorine. F2 bond you can break, then it gives F plus F. You can break this bond, energy is released. Why? Because fluorine is more electronegative element. That's the reason energy is released. Energy released, it is exothermic process. Exothermic process minus 38. Fluorine value is not given, no, take it as 0. Now simplify. Simplify, then you will get a 292 kilocalorie per mole. Third option correct. The dissociation equilibrium of a gas AB2 can be represented as 2AB2 gives rise to 2AB plus B2. The degree of dissociation of X and is small compared to 1. And it is small compared to 1. Okay. The expression relating the degree of dissociation X with equilibrium constant Kp and total pressure P is, okay, initially 2 moles of the reactants, number of moles of product is equals to 0. Then X amount of the substance is dissociated, 2 minus 2x, 2x, x. Total number of moles, this is at equilibrium. Total number of moles at equilibrium is equals to 2 minus 2x plus 2x plus x. Minus 2x plus 2x cancel. Then total number of moles is equals to 2 plus x number of moles. We know that Kp is equals to partial pressure of AB whole square into partial pressure of B2 by partial pressure of AB2 whole square. Now apply Dalton's law. According to Dalton's law, partial pressure is equals to total pressure into mole fraction. If you want partial pressure of AB, partial pressure of AB is equals to total pressure P into mole fraction of AB. Mole fraction of AB is number of moles of AB by total number of moles of all components. Total number of moles is 2 plus x. Partial pressure of B2 calculate. Partial pressure is equals to total pressure into number of moles of B2 is x. Total number of moles is 2 plus x. Partial pressure of AB2. Total pressure into number of moles 2 minus 2x by 2 plus x. Substitute the values. Then P into 2x by 2 plus x whole square, Px by 2 plus x whole divides with P into 2 minus 2x by 2 plus x whole square. Now simplify. You can simplify, then you will get Kp is equals to x cube P by 2 plus X whole divides with 4 into 1 minus X whole square. In the question, condition is given X, dissociation is X and it is small compared to 1. So 2 plus X, according to the given condition, X value is very small compared to 1 also. 2 plus X is equals to 2 and 1 minus X is equals to 1. Substitute, then Kp is equals to 4x cube P by 2 whole divides with 4. Then x is equals to Kp is equals to Px cube by 2. X cube by 2. No, check it. Yes. This is nothing but 4 by 1. 4 by 1 reciprocate 1 by 4. Yes. Then you will get 4x cube P by 8. Question is, now 8 Kp is equals to 4p x cube. X cube is equals to 2 Kp by P. X is equals to 2 Kp by P whole power 1 by 3. Based on the given conditions, identify the type of reaction. A gives rise to 2B. Equilibrium temperature increases, equilibrium constant value decreases. So it is exothermic reaction. Here temperature increases, equilibrium constant value also increases. So endothermic reaction. 1 is exothermic, 2 is endothermic. 20 ml of H2SO4 solution can exactly neutralize 40 ml of NaOH solution of POH is equals to 1.301. pH of H2SO4 solution is, okay, given POH value is given, NaOH solution of POH value is given 1.3010. Then OH minus ion concentration is equals to 10 power minus 1.3010. That is OH minus ion concentration is equals to anti-log of minus 1.3010. Now it can be also written as minus 1.3010 is also written as minus 2 plus 0.6990. Anti-log of minus 2 plus 0.6990. Minus 2 can be written in terms of scientific notation 0.6990. Log 5 value is 0.6990. So OH minus ion concentration is 5 into 10 power minus 2. Now based on this, we know, based on given POH, I calculated OH minus ion concentration. H2SO4 is acid, NaOH is base. Now apply neutralization concept. Apply neutralization concept. N1V1 is equals to N2V2. N1 calculate into volume of H2SO4 is 20 ml. N2 concentration is 5 into 10 power minus 2 into 40 ml. Then N1 is equals to 5 into 10 power minus 2 into 40 by 20. Simplify. Then you will get 10 power minus 1 normal. What is the question now? Calculate pH of H2SO4. I know the concentration of H2SO4. pH is equals to formula is negative logarithm of H plus ion concentration. H plus ion concentration is equals to, how to calculate H plus ion concentration? Mk, molarity into valency. Molarity into valency is nothing but normality. So negative log of 10 power minus 1 minus into minus plus 1 log 10. 1 log 10 value is 1. First option correct. pH of a dibasic acid is given. Its molarity. Generally, H plus ion concentration is equals to Mk. Here K value is given. K value is given as it is a dibasic acid. So K value is taken as 2. Calculate H plus ion concentration. pH is equals to 3.699. H plus ion concentration is equals to 10 power minus 3.699. Anti-log of minus 3.699. Negative anti-log this is. So next number you can take, it can be also written as minus 4 plus 0.3010. So number can be written as scientific notation 10 power minus 4. Log 2 value is 0.3010. So H plus ion concentration is 2 into 10 power minus 4. 2 into 10 power minus 4 is equals to, calculate the molarity. Dibasic acid, so K value is equals to 2. Then M is equals to 2 into 10 power minus 4 by 2. 1 into 10 power minus 4. The IUPAC name of the following compound. In this compound, carboxylic acid group is present. Carboxylic acid group is high priority group. 1, 2, 3, 4, 5, 6. Sixth position, OCH3 group is present. So 6-methoxy, fourth option. 6-methoxy, sixth one is carbonyl carbon. Second position, fifth position methyl groups are present. So correct answer is 6-methoxy carbonyl 2,5 dimethyl hexanoic acid. Statement 1. N-butane and isobutane are distinguished by potassium permanganate. Wrong. KMnO4 is used to identify unsaturated hydrocarbon. That means KMnO4 is reacts with unsaturated hydrocarbons only, not reacts with alkanes. KMnO4 reacts with alkenes and alkynes. Benzene and other polynuclear hydrocarbons containing more than 2 benzene rings fused together are carcinogenic. Yes. Polynuclear are carcinogenic. Correct. Statement 1 false. Statement 2 correct. Benzene reacts with C2H5Cl in the presence of Lewis acid. This is Friedel-Crafts alkylation. Then it gives C6H5, C2H5, ethyl benzene. Ethyl benzene reacts with KMnO4. Side chain oxidation process takes place and it gives benzoic acid as a product. Side chain oxidation irrespective of carbon chain length. Correct answer is second one. CH bond length in acetylene is 1.06 angstroms and that in ethylene is 1.09 angstroms. Correct. CH bond in acetylene is due to sp-s overlapping, whereas ethylene is due to sp2s overlapping. This is also correct. Both the statements are correct. Acetylene is alkyne. Acetylene is alkyne. Alkynes carbon atom undergoes sp hybridization. Ethylene is alkene. In alkenes carbon atom undergoes sp2 hybridization. So based on that, carbon hydrogen sp-s bond, carbon hydrogen bond is sp2s bond. Both the statements correct. A reacts with chlorine gives B, B reacts with alcoholic KOH gives C, excess sodium gives D, excess CH3I gives X, reacts with sodium by ammonia gives Y. Okay, sodium by ammonia. Okay. A is an organic compound obtained by dehydration of C2H5OH with concentrated H2SO4. C2H5OH reacts with con H2SO4 at high temperature, then it gives C2H4. Okay, A is C2H4, A is identified, CH2 double bond CH2 plus Cl2, then addition reaction takes place, CH2Cl, CH2Cl reacts with a alcoholic KOH and sodamide. Both are acts as dehydrohalogenating agents. Remove HX. Again remove HX. Why? Both are dehydrohalogenating agents. Then it gives CH triple bond CH. Reacts with a excess sodium. Excess sodium. Then it gives CNA triple bond CNA. Reacts with the excess CH3I, reacts with excess CH3I, then it gives CH3C triple bond C CH3. Finally it reacts with sodium ammonia, then it gives transbutane. Sodium ammonia gives transbutane, CH3 CH3 hydrogen hydrogen. Reaction is alkyne. Alkyne undergoes reduction in the presence of palladium carbon. Cis-alkene is the product. In the presence of sodium ammonia, then product is transalkane. Check NCERT textbook once. Which graph indicates Henry's law between pressure of gas versus mole fraction? Third one. Because P is equals to KH into mole fraction, it is in the form of Y is equals to mx, straight line passed from origin. Osmotic pressure of solution of a polymer in cyclohexanone at 300 kelvins are plotted on the graph. The molar mass of polymer is. Osmotic pressure pi is equals to CRT formula. Concentration is expressed in terms of molarity. Pi is equals to N by V into RT. Number of moles is equals to weight by molecular weight. Weight by volume into RT by W. Here concentration is expressed in terms of gram per liter. That's the reason weight by volume I am taken in terms of concentration. This is in the form of Y is equals to mx. On y-axis pi, x-axis take W by V. Slope. Slope is equals to RT by molecular weight. Question is calculate molecular weight. Molecular weight is equals to RT by slope. R value 0.083 into temperature 300 by 5 into 10 power minus 5. Simplify, then you will get 49,800 grams. Sorry, not 49,800, 4,98,000. Simplify. Electrolysis of fused NaCl. Given fused NaCl. In fused NaCl, cation is Na plus, anion is Cl minus. Cation is Na plus, so at cathode sodium is deposited. Electrical potential of Zn plus Cu2 plus gives rise to Zn2 plus Cu is 1.1 volts. When it is connected to an external cell potential of less than 1.1 volts, then the electron flow from zinc rod to copper rod, correct. Current flow from copper rod to zinc rod, but here given zinc rod to copper rod, wrong, because electron flow is always opposite to current flow. Zinc deposits at anode, no, wrong. Zinc dissolves at anode, copper dissolves at cathode, copper deposited at cathode, wrong. Incorrect statements B, C, D are incorrect. A first order reaction has a rate constant of 2.303 into 10 power minus 3 second inverse. The time required for 40 grams of this reactant to reduce to 10 grams will be. Calculate the time. Time is equals to 2.303 by K value. 2.303 into 10 power minus 3 log of initial concentration 40, final concentration 10. 2.303, 2.303 cancel. 1 by 10 power minus 3. 1000 into log 4. That is equals to 1000 into log 4 value 0.6020. You will get 602 seconds. First option correct. A plus B gives rise to product. Dx by dt value is given as k into a power a, b power b. If dx by dt is equals to k, dx by dt value is equals to k means a power 0, b power 0 you can take. Then dx by dt value is equals to k and order of the reaction is sum of powers. 0 plus 0 is equals to 0. Units of frequency factor A in. Remember one point. Units of K is equals to units of frequency factor. K units is depends upon order of the reaction. So frequency factor is also depends upon order of the reaction. Pick out wrong statement regarding 15th group elements. Reducing power increases from NH3 to BiH3, correct. Because reducing power is directly proportional to MH bond length. NF3 is most stable trihalide of nitrogen, correct. Nitrogen can form d-pi bonds. No, this is incorrect. Because nitrogen is able to form p-pi type of bonds. Incorrect. Single NN bond is weaker than PP bond. Yes, this is also correct. Statement 1. In the case of nitrogen, all oxidation states from +1 to +4 tends to disproportionate in acid solutions. Correct statement. Statement is correct. pH3 has lower boiling point than NH3. Correct. Statement 1 correct. Statement 2 is also correct. Among the following, which is liquid at room temperature? SF4 is gas, SeF4 is liquid. Ions with 4F7 configuration. EU2 plus, Europium 2 plus, yes, 4F7 configuration. Gadolinium 3 plus, 4F7 configuration. EU3 plus, 4F6, no. Terbium 3 plus, no. Samarium 2 plus, no. Only A and B, 4F7 configuration. Cu2 plus aqueous more stable than Cu plus. See, yes, Cu2 plus is more stable than Cu plus. Cu2 plus hydration enthalpy is more negative than Cu plus, which compensate for the second ionization enthalpy of copper. Yes, A is true, R is true, R explains A. Identify homoleptic complexes. First identify homoleptic complexes. Homoleptic. Around the central atom only one type of ligand is present, that is homoleptic. So remove E and C. Here E option is present, wrong. Here C option is present, wrong. Okay. Now with an odd number of electrons, calculate the oxidation state of iron. Iron oxidation state is Fe2 plus. Fe2 plus electronic configuration is argon 3d2, 3d2, d2, even number of electrons. Next, FeCN6 3 minus. FeCN6 3 minus. Iron is in 3 plus oxidation state. Then electronic configuration is argon 3d5. D5 is odd number. COCl4 2 minus. Cobalt is in 2 plus oxidation state. Argon 3d7. D7 is odd number. So B, D. First option correct. The complex that show fascial marginal isomerism. Ma3B3 type of molecules are exhibits fascial and marginal type of isomerism. Match the following. Pb2 plus Cu2 plus. H2S gas in presence of dilute HCl. A1. Al3 plus Fe3 plus. NH4OH in the presence of NH4Cl. B3. A1, B3. Still two options are there. CO2 plus Ni2 plus. H2S in the presence of NH4OH. C4. A1, B3, C4. Second option is correct. 2-methyl propyl bromide reacts with C2H5O minus gives A. Reacts with C2H5O minus. It is polar aprotic solvent. Polar aprotic solvent follows SN2 mechanism. Remove Br minus. In the place of Br minus substitute OC2H5, then CH3CH, CH3, CH2, OC2H5 gives A, whereas on reaction with the C2H5OH gives B. C2H5OH, polar protic solvent, proton is present, it follows SN1 mechanism. We know that SN1 mechanism, carbocation is formed as a reaction intermediate. Carbocation is formed as a reaction intermediate, so rearrangement takes place. First remove Br minus, CH3CH, CH3, CH2 plus. It is 1 degree carbocation, so hydride shift takes place. Hydride shift takes place and it is converted to hydrogen atom shifted from here to here. CH3C, CH3, positive charge, CH3, 3 degree carbocation. Now B. Now it reacts with C2H5OH, then it gives reacts with C2H5OH, then it gives CH3, CCH3, CH3, OC2H5. Okay. The mechanism followed in these reactions and the products A and B. A, SN2. First option wrong. Fourth option also wrong. Okay. A follows SN2 mechanism and name of the product is, this is isobutyl group. Isobutyl ethyl ether. Isobutyl ethyl ether. Based on that, third option correct. The ascending order of acidity of OH groups in the following: aromatic, 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 aromatic. This is aliphatic. Aliphatic alcohols. Aliphatic alcohols are least acidic. Least acidic. NO2 electron withdrawing group, electron donating group, no electron donating or withdrawing group, electron withdrawing groups. Number of electron withdrawing groups are increases, acidic nature increases. Ends with E, starts with A. Ends with E, starts with A. Okay. E before B. B before D. D before, this is electron donating group, C. Correct option, fourth option. Acidic nature directly proportional to number of electron withdrawing groups, directly proportional to electron withdrawing group, inversely proportional to electron donating group. Both acetaldehyde and acetone individually undergo which of the following reaction? Acetaldehyde CH3C double bond O group is present. It gives iodoform test. Acetone is also gives iodoform test. Due to presence of alpha hydrogens, it does not gives Cannizzaro reaction. Both gives aldol condensation reaction due to presence of alpha hydrogens. Tollens reagent test. Tollens reagent test. Aldehydes gives but ketones does not gives. Clemmensen reduction both gives. So A, C, E. Second option correct. Compound AC8H9Br gives a pale yellow white precipitate. Compound gives pale yellow white precipitate means the compound is aliphatic bromide. Aliphatic bromides or benzylic bromides gives pale yellow white precipitates when it reacts when warmed with alcoholic AgNO3. Oxidation of A gives an acid. B easily forms anhydride on heating. Okay. Take the fourth option. CH2Br CH3. On oxidation, use KMnO4. Irrespective of carbon chain length, alkyl bromides are undergoes carboxylic acid. Alkyl group is also undergoes carboxylic acid. Both are in adjacent position with respect to each other, ortho position. So easily forms anhydride. C double bond O, C double bond. So correct option is fourth option. Okay. Identify Q and S and what is the relationship between Q and S. BH3 plus THF H2O2 OH minus hydroboration oxidation. Add water molecule, it follows anti-Markovnikov's rule. Add hydrogen atom, unsaturated carbon which contains less number of hydrogens. It gives 1 degree alcohol. 1 degree alcohol reacts with PCC or PDC. Oxidation takes place and it gives aldehyde. HgOAc twice NaBH4. Oxymercuration demercuration follows Markovnikov's rule. Add hydrogen atom to unsaturated carbon which contains more number of hydrogens. It gives 2 degree alcohol. 2 degree alcohol reacts with PCC. Then it gives ketone CH3COCH3. This is aldehyde. This is ketone. Aldehydes and ketones are functional isomers. Which of the following statement regarding amino acids are correct? Proteins on hydrolysis gives alpha amino acids. Glutamic acid contains more number of amino group, no, more number of COOH groups. Amino acids with equal number of amino and carboxyl group are neutral amino acids, correct. All naturally occurring amino acids are optically active, wrong. Here glycine is optically inactive. Optically inactive. Based on this, first option. For reaction, the correct order of set of reagents for the above conversion. Second option is correct. Not third option. Second option is correct. Why? NH2 group is highly activating group. The NH2 group is treated with H2SO4. If NH2 group is treated with H2SO4, then what happened? It blocks para position. It blocks para position. Now it blocks para position SO3H. Now it reacts with AC2O. Then acetanilide it gives NHCO CH3 SO3H. Now acetanilide it reacts with bromine. Substitute bromine atom at ortho position NHCO CH3 SO3H bromine. Finally H2O add NaOH. First add H2O, then it gives NH2 Br SO3H. It reacts with the NaOH. SO3H acid, NaOH base, acid base reaction takes place. Finally it gives NH2Br as a major product. Match the following. Schwarz reaction, alkyl fluorides A4. Sandmeyer reaction, chlorobenzene, bromobenzene, cyanobenzene, A4B3. Third option correct option. Yes. Thank you.